common emitter. Same way. So next is N, P and N. So here common emitter, right? So this is emitter and this is base and this is collector. So this terminal you need to take common for both input and output. So this is an input terminal and this is an output terminal. Okay. So here also N, the charge carrier has to move away from the battery, so it has to repel. So how we will make it repel is that you need to connect the same thing. So negative and here P to positive. And this side all the charge carriers you need to collect, so it has to accept or it has to attract. That means all the negative charge carriers here has to be get attracted. So you will connect a positive, so opposite charge will get attracted. So this side it is positive and this side it is negative. So I will draw the flow. Emitter, collector and base. Again an ammeter to calculate an input current and voltmeter to calculate this side. This is an output, so output voltage, and battery collector is connected to positive and emitter is connected to negative. Again this side it is ammeter to calculate the input voltage, voltmeter to calculate the input voltage, and this side battery B is connected to positive and E is connected to negative. So this is the graph. Here what is input current? Input current which is measured by ammeter A1, V1, A2, V2. So A1 input current is IB. Okay. So what is the input voltage which is calculated by V1 is across this one. So VBE. Okay. So output current is measured by ammeter 2. So output current is collector, that is IC, and output voltage measured by voltmeter 2. So the voltage is across this one. So VCE. Okay. So this is how we are connecting a battery for common emitter configuration, and these are the input voltage and output voltage. Similarly, let's check for input characteristics and output characteristics. So input characteristics is you need to plot a graph against input current, input voltage by making an output voltage constant. So what is input current? Input current is IB, input voltage is VBE. IB, VBE. What is output voltage? Output voltage is VCE. So VCE is made constant. Similarly, for output characteristics, you need to plot against output current, output voltage by making input current constant. So what is output current and output voltage? IC and VCE. IC and output voltage is VCE. What is this input current? Input current is IB. So this IB is made constant. Okay. So let's plot a graph. Plotting a graph is against IB and VB. Here also, if you see, this input circuit is acting as a transistor or a PN diode in forward bias condition, because P is positive and N is negative. So this input circuit or PN diode is acting as a um, acting in a forward bias condition. So similarly, like the same one here also, you will get when you increase an input voltage, the current will not flow till the new voltage or say 0.7 volt, and once it reaches 0.7 the current starts flowing. Here VCE is made constant, so you can make it like a 20 volt. So next, when VCE is 10 volt, then you will have like this again 5 volt. Okay, so here, like a previous condition, the input circuit is acting as a PN diode and it's forward bias condition. So till 0.7 volt no current will flow, then once it reaches at 0.7 volt the current starts flowing. Here for an output circuit it is same, because the concept is same. Whatever the input emitter current is applied, that collector current has to receive the entire input current or emitter current. So how much ever voltage you increase, once it reached its maximum, then it will become constant like the previous case. So here also output voltage is VCE and output voltage is current. Say if you are increasing VCE, the current starts increasing. Once it reached its maximum, then it will become constant. So once it reached its maximum, then it becomes constant. Sorry, this is IB is constant. Here input current is IB. So IB will be, say if you are using 10 microamps. Say next, if you are changing it to 20 microamps, then IB will be 20. Or still more, if you are increasing, it will be like this. Okay, so plotting the graph for common base and common emitter is same. By looking at this, let's calculate an input resistor. R in is equals to V in by IE. So what is input voltage? Input voltage is VBE. What is input current is IB. So we are calculating with respect to change, so that's why I mentioned del. So what is this output resistor? So R out is V out by I output current. So V del VC V by del I. Okay. So this is the input resistor and this is the output resistor. Here you are using an VC as constant. Here IB as constant. So this is input resistor and output resistor. Now let's calculate current gain. Current gain is output current by input current. What is output current? Output current is IC. What is input current? Input current is IB. Last is voltage gain. Voltage gain is output voltage by input voltage. So output voltage is VCE. Input voltage is VBE. Okay. So this is the 4 characteristics we have drawn similar to common base configuration.